has a charge of 500 microcoulomb and length of 10 centimeter. Then find its electric field at a point of 20 centimeter apart from center of dipole along its axis. So electric dipole, we have two equal and opposite charges. So on 500 microcoulomb and 500 microcoulomb. Okay. So minus 500 microcoulomb and plus 500 microcoulomb. Then it is separated by a distance of 10 centimeter. 10 centimeter. Okay. Then you have to find the electric field at a point of 20 centimeter apart from center of the dipole. So from the center of the dipole, this is the axis of the electric dipole. Okay. The line joining minus Q1 plus Q, you call it as axis of the dipole. So you have to find the electric field at a point 20 centimeter from the center. So from the center, okay, from the center of your axis, so to a point P. Okay, so from the center of the axis to a point P, it is 20 centimeter. Okay, so you have to find the electric field due to this dipole at the point P. Okay, this you call it as electric field of a dipole at the axis. Okay, along the axial line you call it as. So at this point P, the electric field due to this positive charge will be along in this direction. Okay. Okay, and the electric field of this negative charge, okay, will be along in this direction. Okay, so both will be of equal magnitude but opposite sign. Okay, so now we know the formula for electric field at an axial axis. Okay, so that is given by electric field at a point in axial line is given by E is equal to 2 into K into P divided by R cube. Okay, so 2 into, we know that K is your Coulomb's constant, 2 into 9 into 10 to the power of 9 into P is a dipole moment. So what is P? P is equal to Q into 2L divided by R. R is equal to 20 centimeter. Okay, so convert to meter, get 10 power minus 2 the whole cube. Okay, so we have the value, substitute the values, 2 into 9 into 10 to the power of 9 into what is Q? Q is equal to 500 microcoulomb. So 500 into 10 to the power of minus 6 into 2L value. Here it is 2E, right? 2L value is 10 centimeters. So 10 into 10 to the power of minus 2 divided by 20 into 10 to the power of minus 2 the whole cube. Okay, so you'll get the answer after dividing those values. You'll get the answer to be 1.125 into 10 to the power of 8 Newton per coulomb is the unit for electric field. Okay, so this is the answer. Okay, so we'll see the option, given option 1.125 10 to 8 is the option A is the answer. So A is the answer. Okay, so are you able to get? They asked to find the electric field at a point along the axial line. Okay, due to this dipole, what is the electric field at a point P in the axis, along the axis line, what is the electric field? So use this formula, E is equal to 2 into Kp divided by R cube. Substitute the values, given values, then you will get the electric field, magnitude of this electric field. Now they asked an equatorial position at a point of 20 centimeter. Okay, so equatorial is, we have two charges, K minus Q plus Q charges. So equatorial is along the axis line perpendicular to this axis line. Okay, perpendicular to this axis line, we have the equatorial point P. Okay, so at this point P, what is the electric field? We have to find out. Okay, so we know the formula for this equatorial electric field of an equatorial point. E is equal to minus kb divided by r cube, where this minus denotes the direction of the electric field is opposite to that of dipole moment. Okay, so we'll get minus 9 into 10 to the power of 9 into P is equal to Q into 2L divided by R cube is 20 into 10 to the power of minus 2 the whole cube. Okay, so it is a continuation of the same problem. So the given values, we know that Q is equal to 500 microcoulomb and 2L is equal to 10 centimeter, which is equal to 10 into 10 to the power of minus 2 meter. Okay, so substitute, we will get the values of minus 5.625 into 10 to the power of 7 Newton per coulomb. This is at a point in equatorial position. Okay, so from this what we have to understand is, you can find the electric field of a dipole in an equatorial point, that is perpendicular to the axis as well as along the axis. Then what is the magnitude of the electric field at a point in axial line as well as at a point in a perpendicular to the axis, you can find out. Okay, so using these two formulas, E is equal to 2 kV by R cube and E is equal to minus kV by R cube. Making use of this formula, you can find out the magnitude at the electric field at a point along the axis as well as perpendicular to the axis. Okay, now next question is, force between two short electric dipoles separated by a distance r is directly proportional to 1 by r square, 1 by r4, 1 by r cube, 1 by r. Okay, so force between two short electric dipoles. We have two dipoles. Okay, so let this be one dipole. Okay, set. I have minus charge and plus charge, and this is another dipole. Okay, so both are separated by a distance of r. This is one dipole pair and this is another dipole pair. So both are separated by a distance of r. Okay, this is what is given. So we know that potential energy of the dipole is given by U is equal to minus P E cos theta. Okay, so P is the dipole moment. Okay, and E is the electric field and theta is the angle. So what is E along the axial line? E is equal to 2 kP divided by R cube. Okay, so therefore U will be equal to minus P into 2 kP by R cube, okay, into cos theta. So here theta is equal to, along the axial line, theta is 0. Theta is equal to 0 degree along the axis. Okay, so theta is the value between the angle found between the electric field and the dipole moment along the axial line. Theta is equal to 0. Therefore, cos 0 is 1. Okay, so therefore U will be equal to minus 2 K, okay, P, okay, divided by R cube into P. Okay, so we have to find the electric field, relation between the force and the distance between them. Okay, so let this to differentiate the dipole moment along from the point, right? This P denotes dipole moment, so let we consider to be P dash. Okay, and this U is a potential energy E is equal to minus P into cos theta, let it be P, and the electric field dipole moment, let it be P dash, to make the differentiate between. Okay. Okay, now what is force? Force is equal to minus du by dr. Okay, so just differentiate this, you get minus d into 2k p dash by r cube. You can take the constants outside. Okay, take the constants outside, you get 2 into k into p dash by differentiation of 1 by r cube. Okay, so here you have minus sign, here you have minus sign, so minus minus becomes plus here. So differentiate this, you'll get 2k p dash, you can write it as this r minus 3. Okay, differentiation of r minus 3 with respect to r. Okay, so after differentiating we'll get the answer to be minus 6k p dash divided by r to the power of 4. So F is equal to, okay, minus 6k p dash divided by r to the power of 4. Okay, so from this we conclude that F is inversely proportional to 1 by r. For force is inversely proportional to separation between them. Okay, so separation between two dipoles, force between the two dipoles, separation will be inversely proportional to 1 by r4. So option is B. Okay, so answer is B. So what you done is, this is the potential energy of the dipole moment. U denotes for energy. So in this formula, here substitute what is the electric field. Okay, just substitute this formula for electric field along the axial line. Then theta value is 0. Since it's axial line, there is no angle formed. Then we'll get U is equal to minus 2k pv dash divided by r cube. Then we want to find force. So relation between the force F is equal to minus d differentiation of energy with respect to the separation distance r. So just substitute and differentiate it, then you find the final expression to be inversely proportional to 1 by r4. Force to be inversely proportional to 1 by r4. Okay, next is, in an electric dipole, okay, is kept in a uniform electric field. If an electric dipole is kept in a uniform electric field, then resultant electric force on it is always 0, never 0, depends on dipole capacity. So this is a dipole that is given placed in uniform electric field. Okay, so in uniform electric field, the strength will be uniform and the force exerted by this positive charge, okay, will be in along this direction, and the force exerted by the negative. So dipole is minus q plus q. The dipole separated by a distance of d is placed in a uniform magnetic field. The dipole moment will be from minus q to plus q, and the force experienced by this plus q charge will be in this direction. The force experienced by the minus q charge, negative charge, will be in this direction. Okay, so the two forces will be equal and opposite direction. So we know that what is the relation between electric field and force? Electric field is equal to force per unit charge, right? So F is equal to Q into E. Okay, this is the relationship. So due to positive charge, the force direction will be away. Okay, so it will be moving away, and force due to negative charge also will be moving towards the. So imagine that this uniform electric field line is due to the point charges placed here. Okay, so point charges are placed here. The electric field line will be from positive charge. Okay, it will be positive point charges be placed here. So electric field uniformly will be from positive to negative charge. Okay, and when you place a positive charge q here, what happens? This positive and positive gets repelled, so force will be in this direction. So when you place a negative charge here, then this negative charge will be attracted by this positive charge. Okay, so force will be in this direction. Are you able to get? So this is a positive charge plus Q gets repelled by this positive charge, so the force direction will be here, and this negative charge minus Q will be attracted by this positive, so the force direction will be towards the positive charge, and here force direction plus Q will be away from the, this is a repulsive force and this is an attractive force. Okay, so these two forces will be equal in opposite directions, so the net force will be equal to 0. Okay, both are equal in opposite direction, so net force will be equal to 0. So answer is always 0. For uniform electric field, force will be equal in a dipole. So net force will be 0. Force due to two charges will be equal, so net force is equal to 0. An electric dipole is placed at an angle of 30 degrees to a non-uniform electric field. The dipole will experience what? So uniform electric field, you have the strength of the field to be uniform. For a non-uniform electric field, strength will be a varying one. Field lines will be a varying one. Okay. Now you place the electric dipole along this. Okay, let it be one end be here, other end be here. Okay, let it be plus Q. This is minus Q. This is an electric dipole placed in a non-uniform electric field. So when you observe this diagram, you can see that the electric field lines are not uniform. Okay, they are going wider here and they are closer to here. So where it is closer, it will be having a strong electric field. When this wider part, you have a less electric field. Now imagine this setup. Plus Q and minus Q is located at a point A and B. Okay, so if electric field at this point A, okay, if electric field at point A is greater than electric field at point B, that is here the electric field is more, okay, and because it's non-uniform, and we are assumed that B to be lesser, so EA is greater than EB. Then the force experienced by this positive charge, let it be F dash, and the force experienced by this minus Q, okay, will be in this direction. Okay, let it be F. Okay, so F dash and F, when you compare F dash and F dash will be greater than F. So this F dash is not equal to F. In the earlier case, we found that the force experienced where two charges are equal. In this case, when the non-uniform electric field, uniform field strength is not uniform, so the force experienced by the charges also will not be equal. Here we assume that A force, the electric field at this point A is greater than that of B, and we say that F dash is greater than F. It's not equal. Therefore, both are not equal. So when both are not equal, okay, then we have force existing on it as well as torque. Okay, so dipole will start to give a linear rotation. Okay, that you call as torque. So both force and torque will be present in a non-uniform field. Okay, so answer is this force gives a linear force said to be a translational force. So option is C, non-uniform field, you have both torque and translational force. In a uniform field, you have, okay, force to be 0 and you have a torque alone. There is no, since force is 0, we have only torque. Okay? Linear rotation of this dipole will be there. Okay, when the dipole is placed at some angle, there will be linear rotation of this dipole to align with that of an electric field. Okay, so non-uniform field, you have force and torque existing in the dipole. In the uniform field, you don't have force, you have only torque. Only torque is there. Okay, next question. Electric dipole having 2 into 10 to the power of minus 6 coulomb charge, each separated by a distance of 2 centimeter, is placed in an electric field of 2 into 10 to the power of 5 Newton per coulomb. The maximum torque exerted on dipole is. Okay, so charge is, okay, so charge are given as 2 into 10 to the power of minus 6 coulomb separated by a distance of 2 centimeter. Okay, so this 2D distance is of 2 centimeter, which is equal to 2 into 10 to the power of minus 2 meter. Okay. Okay. Now is placed in electric field value is 2 into 10 to the power of 5 Newton per coulomb. Now we have to find a maximum torque exerted by the dipole. Okay. So when a dipole is placed in electric field, torque is produced. Okay. And this torque will align the dipole towards the electric field. Okay. So now we have to find the torque. So torque is equal to P is sin theta. Okay. So now in the uniform electric field, the torque, okay, the uniform field, you have to draw the image line all of equal length. You place a dipole here. Okay, plus Q and minus Q separated by a distance of 2D, and let it be aligned at some angle theta. Okay, due to this force gets 0, we already seen, and you have a torque produced by this dipole. We have said that we have to find the maximum torque. So get maximum torque. When does we get the maximum torque? When theta is 90 degree. Okay, sin 90 is 1. So maximum torque is obtained when theta is 90 degree. Okay, so tau is equal to P for maximum. Okay, sin 90 is 1, so we'll get max. So what is P? P is equal to Q into 2D. Okay, E value is given. Just substitute the values. Okay, so Q value is 2 into 10 to the power of minus 6 into 2 into 10 to the power of minus 2 into 2 into 10 to the power of 5. Okay. Okay. Q into 2D. Okay. So you get the answer as 8 into 10 to the power of minus 3 Newton meter. Newton meter is a unit for torque, and this is the symbol for torque, and this is the unit for torque. Okay. So answer is 8 into 10 to the power of minus 3 Newton meter. So this is the formula for torque. After deriving, we'll get this formula, and in this you substitute theta is 90 degree for torque maximum. Now next question is, on decreasing the distance between the two charges of a dipole which is perpendicular to electric field and decreasing the angle between the dipole and electric field, the torque on the dipole will be. Okay, so torque is given by P sin theta. So if the distance between the two charges is decreased, so what is dipole moment? P is equal to Q into the distance. Okay, so if distance is decreased, yes, distance is decreased. Okay, as well as the angle between them is theta is also decreased. So when distance is decreased, then P also gets decreased. Okay, and theta is also decreased. Okay, so P gets decreased. Okay, theta is also decreased, so therefore the torque also gets decreased. Okay, so option is A. So when you decrease the length between the two charges as well as angle, inclined angle between the charge and the electric field, then we get the tau to be decreased. So next is an electric dipole of 4 cm placed at an angle of 30 degree with an electric field intensity of 2 into 10 to the power of 5 Newton per coulomb. Dipole experiences a torque of 4 Newton meter. Then the charge on the dipole is, what is the charge on the dipole? okay, of 4 centimeter placed at an angle of 30 degree. Okay, so torque, the given value is 4 Newton meter, and electric field intensity is 2 into 10 to the power of 5 Newton per coulomb, and theta aligned values, so dipole with that of electric field, theta value is 30 degree. Okay, and okay, and the distance is of 4 centimeter they have given. Okay, now we know the formula for torque is equal to P into E. Okay, so what is P? P is equal to Q into 2D. Okay, so you can substitute here, then we can find out what is P value from this. Okay, so P will be equal to tau divided by E. Okay, so what is tau? Tau is 4 divided by, okay, 2 into 10 to the power of 5. Tau is equal to, tau is equal to P sine theta, right? 2 into 10 to the power of 5. Okay, so just we 4 into 4 Newton divided by 2 into 10 to the power of 5. Okay, so from this we'll get P is equal to, what is sine theta? Sine theta will be equal to sine 30 degree will be equal to 1 by 2. Okay, so substitute this value, we'll get 4 divided by 2 into 10 to the power of 5, sine theta value is 1 by 2. So that 1 by 2 also we'll get here. So we'll get P is equal to 4 into 10 to the power of minus 5 coulomb meter. Okay, so you have tau is equal to P sine theta. Okay, so from this you can find P is equal to tau divided by E sine theta, so which is equal to 4 divided by 2 into 10 to the power of 5. Sine theta 30 degrees 1 by 2. Just substitute the values, we'll get P is equal to 4 into 10 to the power of minus 5. Okay, so we know the formula for the dipole moment. P is equal to Q into 2D distance, that is L distance. Okay, so from this we can calculate what is Q. Q is equal to P by 2D. Okay, so from the question, what is the 2D value? 2D value is given as 4 centimeter. Okay, so given 2D is equal to 4 centimeter, which is equal to 4 into 10 to the power of minus 2 meter. Therefore, Q is equal to P is 4 into 10 to the power of minus 5 divided by 4 into 10 to the power of minus 2. So we'll get the answer to be 1 millicoulomb. So Q is equal to 1 millicoulomb is the answer. Okay, so we have the torque formula. From the torque formula, we are calculating what is dipole moment. From the dipole moment, we are calculating what is the charge. We have to find the charge on the dipole. Okay, so we have seen the problems related to electric dipole torque. Okay, hope you have understood this. So kindly subscribe, like and share to your friends. Thank you.